Hello student, welcome to my class. Last class we discussed refraction takes place in spherical surface, and we already discussed three cases of convex refracting spherical surface. Clear now? The last case of convex spherical refracting surface, that means we get a virtual image if object lies inside denser medium. Clear? Now we have to find a virtual image if object lies inside denser medium, and by using convex spherical refracting surface. Suppose there is a convex spherical refracting surface like this, and the object which lies in denser medium, this is principal axis, and this point is P, and this point is center of curvature. This is denser medium of refractive index mu2, and this is rarer medium of refractive index mu1. But here we have to find a virtual image. So now place a object or point object on the principal axis which in between C and P. Clear? Now this point, suppose take this point object here, this point O. Clear? Now the ray of light which incident from point object O and which strike at point A, this point, this is the actual path, or this is the line of action of incident ray, like this. Now we have to draw a normal at this point. So this normal which pass through the center of curvature, this is normal, this point, this is normal, and again the ray of light when traveling from denser to rarer medium, it bends away from the normal. This is actual path, it's bent away from the normal, and which this is incident point. The ray diagram should be perfect. So this direction, and which if this ray traveling away from the normal like this direction, or this direction, this is refracted ray, and which appears to meet this point I. If another ray which traveling this direction, this is incident, first ray, this second ray, which traveling on the principal axis and ultimately pass this direction, then this is the intersection point, and this image is known as virtual image. Why? Because the refracted ray which traveling this direction and its producing line which meet the principal axis at point I. So it form a virtual image. So first we have to draw a angle of incidence. So it is the angle between normal and incident ray. So this angle is known as angle of incident. Again, what is angle of refraction? It is the angle made by refracted ray, this ray, refracted ray, and refracted ray with this normal, and this angle is known as R. Suppose this angle, object angle, suppose alpha, this angle is beta, and this angle is gamma. Now we have to draw a perpendicular here. This point A, this is a perpendicular, and which meet at point B. This angle is beta here. This is perpendicular and this is beta, which meet at point B perpendicularly. And here point B and point P and B close, very close to each other. So if we use sign convention here, we can write that is sin I by sin R, Snell's law. By using Snell's law, sin I by sin R, which is equal to this second refracting surface, we can write mu2 or relative refractive index second medium with respect to first, or can write mu1 by mu2. If we cross multiply this, then we can write that is mu2 sin I, which is equal to that is mu1 sin R. For paraxial ray or this aperture is very small, I and R very small quantities, so we can write sin I nearly equal to I, sin R nearly equal to R, or we can write this relation, that is mu2 I equal to that is mu1 R. Now use the value of I and R here. So what is the value of I from this triangle? Look at this triangle, this angle I. So here the angle in triangle CAO I plus gamma equal to alpha or I equal to alpha minus gamma. This is first relation. Next, again this angle is R, and look at this triangle and this total angle also R, because these are vertically opposite angle. Clear? So look at the triangle, that is OAI. In triangle OAI, this triangle CAI, triangle CAI, this triangle, if I draw the diagram CAI, this triangle. Clear? This angle are equal, so this angle is beta, and here this angle also R, this total angle R. Gamma plus R, which is equal to beta, because beta is here exterior angle, so I can write that is gamma plus R, which is equal to beta, and R equal to that is beta minus gamma. Then this is equation number 1, and equation number 2 be that is mu 2 I, and I is here alpha minus gamma, that is mu 1, and mu 1 is R equal to beta minus gamma. So here beta minus gamma. Now use the value of, because alpha, beta, gamma are very small and they can be replaced by their tangent. It is alpha nearly equal to tan alpha, beta nearly equal to tan beta, and gamma nearly equal to tan gamma. Now we can use directly this relation, and here that is mu 2 alpha, which is equal to tan alpha, and the value of tan alpha, right, directly it is tan alpha tan gamma, it is mu 1 tan beta minus tan gamma. From this diagram we can write it is mu 2 tan alpha. Look at this triangle tan alpha OAB. In right angle triangle OAB, this angle 90. So tan alpha, this angle is alpha, that means perpendicular upon base, and here tan alpha equal to triangle OAB. Look at the diagram OAB triangle. Here alpha is base angle, so here perpendicular is here, that is AB divided by base OB, or B and P point are very close, so we can write OB, we can write OP, that is OP or PO. So we can write directly that is PO minus tan gamma. Clear? This angle is gamma. Now look at the triangle CAB. In right angle triangle CAB, then here gamma is base angle, and this is perpendicular, and this is base. Clear? So we can write here that is AB by CB, or you can write CP, or you can write PC. So divided by PC equal to mu 1 tan beta, and this angle beta, and look at the right angle triangle IAB. This right angle triangle beta is here base angle, and so we can write tan beta equal to perpendicular, that is AB by base IB equal to IP or PI. So we can write that is PI minus tan gamma, and here tan gamma, and this is tan gamma AB by that is PC. By using sign convention, we have to find the value of PO, PC and PI. What is PO? PO means this is object distance, this distance is U. Again PC, here the ray of light traveling this direction, because this is incident ray traveling in this direction, so this is the ray of light, this is incident ray direction, this direction. But all the distance are measured which is opposite to ray, because distance are measure object pole. So this image or object distance U, that is PO, which is negative, that is minus U. Why? because this is opposite to the ray of light. Similarly, PC, this distance is r, radius of curvature, and here minus r because which is opposite to, because the incident light we have to measure from this point to this point in this direction, so minus sign. Again pi, this distance is v, or you can write minus v. By using this relation here, AB both side cancel, then mu 2 PO 1 by PO which is equal to minus u minus AB 1 by PC equal to minus r, minus plus into r, which is equal to mu 1 into AB by PI 1 by PI equal to minus v minus 1 by PC, and PC equal to minus r, minus plus r. Now solve this relation. Then if you multiply here, that is mu 2 minus mu 2 by u plus mu 2 by r, that is minus mu 1 v plus, that is mu 1 by r. You have to rearrange one r one side, then here mu 1, so mu 1 by r minus, that is mu 2 by r, which is equal to, here if you take this relation, that is mu 1 v, here another term, that is mu 2 by u. This is the required formula. Clear? This is required formula, and in this case this image is virtual image when object lies between center of curvature and pole, and this is the object lies in denser medium. Clear? And image also form this same denser medium. This is all about refracting surface or convex refracting surface. Now let's start refraction at a convex refracting surface. We already discussed 4 cases of convex spherical refracting surface which form real image and virtual image. So first case of convex spherical refracting surface which form virtual image if object lies in real medium. So first we have to draw a convex spherical refracting surface. So this is the diagram of a convex spherical refracting surface. This is a convex spherical refracting surface like this, and its aperture is very small. The center point of the aperture is known as pole, and because it is a part of the sphere, and this point is known as center of curvature C. Here, if you join the line, if you join a straight line which is passing through center of curvature and pole, this line, straight line is known as principal axis, and this medium is error medium of refractive index mu1, and this medium is denser medium of refractive index mu2. Here the concave surface was separated by 2 medium. Suppose we have to consider here or assumption. What is that assumption? We have to consider a point object, and this aperture is very small, and again the ray should be coaxial. So suppose there is a object, this object O is which beyond the center of curvature, and the object is point object which lies on the principal axis, and the ray is starting from this point object. This is an incident ray, and this is the line of action of incident ray, this direction. Now we have to draw a normal, and this normal will pass through the center of the curvature. Here this normal which pass through the center of curvature. But when light traveling from rarer to denser medium, it changes its direction and it bends towards the normal. So this is the direction of refracted ray, this direction. This is the direction of refracted ray, and which appears to meet this point. Here which appears to meet at this point I. If we again incident another ray which is perpendicular to pole, that is perpendicular to the aperture, then this line which pass on negatively, and this is refracted This is normal, this direction. Now, what is angle of incident? So it is the angle made by incident ray with normal, and this total angle is known as angle of incident, which is denoted by I. Similarly, the angle made by refracted ray with normal, and this angle is known as angle of refraction. So we have to focus on that point, which angle is angle of incident and which angle is angle of refraction. Clear? Now, suppose you draw a perpendicular, suppose this point A. Now we have to draw a perpendicular from O, which strike at point B on the principal axis perpendicularly. And here the point P and point B are very close to each other. Clear? Okay. Now, suppose this distance, this angle is alpha, and the angle which formed by image, suppose this angle is beta, and the angle which formed by normal principal axis, this angle suppose gamma. Clear? Now, this is one refracting surface. So in this refracting surface, if we use Snell's law, by using Snell's law, we can write that is sine of angle of incident divided by sine of refracted angle, which is equal to refraction or refractive index of second medium. This medium, second medium means the refracted ray traveling this medium, that is mu2, and the incident ray coming from this medium, that is mu1. So you can write here that is mu2 divided by mu1. If you cross multiply this, then you can write that is mu1, that is mu1 sine I, which is equal to, that is mu2 sine R. This is Snell's law. Clear? Okay. Since or for partial ray, angle of incident and angle of reflection I and R are very small. So we can write that is sine I nearly equal to I and sine R nearly equal to R. Now, if we replace this term in the above equation, then this above equation can be written that is mu1 I, which is equal to mu2 into R. This is equation number 1. Now we have to find the value of I and R. So look at the diagram. Then in triangle, which triangle? The triangle which consists angle I, this angle, that is triangle OAC. In triangle OAC, the triangle O, A and C, like this. And this one O, A and C, and this angle that is alpha, and this angle that is here OAC, this angle gamma, and this angle is I. This angle of incident I. We already know here gamma is exterior angle, and the exterior angle, that is gamma, which is sum of two interior angle, here alpha plus angle of incident. So I equal to gamma minus alpha. Here now we have to find the value of angle of reflection R. So in triangle we have to find reflecting angle, this angle R. If this angle R, then this angle, and because this is refracted ray and this is the producing ray which meets at point I, and this is normal. So this angle also R. Clear? This angle R and this angle are vertical opposite angle, and this angle is R. So we have to consider which triangle? In triangle IAC. In triangle IAC, this triangle, that means like this. that is IAC. Here the angle C, which is equal to gamma, angle I, which is equal to beta, and angle A. Angle A and C, this angle is known as R, and this angle is known as R. Here also gamma is exterior angle, and exterior angle which is equal to sum of two interior angle, that is beta plus R. But we need the value of R, so R equal to, it is gamma minus beta. This is second relation. Now using the value of angle of incident and angle of refraction in equation 1, this is equation number 1. Then equation 1 can be write from equation 1, that is mu1 I equal to mu2R, and here we can write mu1 I, and the value of I, that is gamma minus alpha equal to mu2 R, means here gamma minus beta. But alpha, beta, gamma are very small, since for partial ray alpha, beta and gamma are very small and they can be replaced by their tangents, so you can write alpha is equal to tan alpha, and similarly beta equal to tan beta, nearly equal to tan beta, and gamma nearly equal to, that is tan gamma for partial ray. So this relation can be write, that is mu1 gamma, that means here tan gamma minus tan alpha equal to mu2, that is tan gamma minus tan beta. This is equation number 2. So first we have to find the value of alpha, tan beta, tan gamma. Now find the value of tan alpha, which is equal to perpendicular upon base. Now look at this diagram. Here this angle is alpha, and look at the right angle triangle OAB. In right angle triangle OAB, alpha is base angle and AB is perpendicular and OB is base. So P equal to AB divided by base, and base is here OB. So OB. But the point P and B are very close to each other, so you can replace B in terms of P, or you can write, that is OP, which is equal to PI, PO. So you can write this term, that is AB divided by P. Next, that is tan beta, and this angle is beta. Look at the right angle triangle IAB. In right angle triangle IAB, beta is base angle and this IB is base, and this is perpendicular. So here, that is perpendicular upon base equal to AB divided by IB, and B can be replaced in terms of P. So you can write, that is PI. Again, that is tan alpha equal to P by B, perpendicular upon base. This angle alpha base angle, this is base, and perpendicular, that is AB. So which is equal to AB by, that is CB, or we can write AB by, that is PC. AB by PC. By using sign convention, to the above relation, then we have to find PO, PI, PC. This PO, PI, and then PC. So look at the diagram. Actually, the incident ray traveling from left to right direction. So this is the direction of incident ray, and if you measure the distance along the direction of incident ray, then the distance is taken to be positive. For the distance which is opposite to incident ray, the distance taken to be negative. This is sign convention. So here, this distance, or the distance always measured from pole, and this distance is known as radius of curvature, and this is image, and this distance is known as V, and this distance is known as object distance, that is Q. So first we have to find PO. This is object distance, and this distance always measure P to O, means opposite to incident ray. So this relation can be write, that is minus U. Object distance is here minus U. Similarly, here the quantical is pi. Pi means image distance is here opposite to incident ray, and the ray that is minus v. Again that is pc, which is opposite to incident ray, that is minus r. If we use this relation in this equation, that is we can write AB divided by PE equal to minus Q and AB divided by minus V EI, and here AB divided by BC, which is equal to minus R. Now if we use this relation alpha, tan beta, tan gamma in equation number 3, so from equation 3 we can write, that is mu1 tan gamma, and the tan gamma, alpha beta gamma. This one is gamma perpendicular upon BC. See this, okay. So tan gamma and the value of tan gamma is equal to AD by minus tan. That is AD by minus tan. Then negative sign minus tan alpha, negative sign tan alpha, which is equal to AD by minus Q and minus plus. So AD by Q equal to refractive index, that is mu2 tan gamma, and tan gamma is here AD by minus R, and again minus of tan beta minus plus, so that quantity that is AD by, that is R, and AD are both sides cancel. The remaining part can be write, that is mu1 by minus R plus, that is mu1 by Q equal to minus mu2 by R, then plus, that is mu2 by R. Now rearrange the term. So if we take here, that is if we take this mu2 by R from this side, then okay, here R on one side, so just rearrange this term, and if we rearrange this term we can write, one mistake is there, that is tan alpha, tan gamma equal to AD by R, tan alpha AD by Q, and that is tan gamma and tan beta. This is tan beta, and the value of tan beta is minus V, and this is minus plus here, that is V, and this term also V. Here now rearrange this equation. Here this is minus mu1 by R. If you take this side, then this is negative positive, and you can write, or if you take this term in left hand side, then here this will be positive, that is mu2 by R, and here a negative sign, that is mu1 by R, which is equal to, there is term, that is mu2 by V, and this side there is mu1 by, which is required relation. Yes, this relation can be written, that is R, if you take LCM R, then this relation, that is mu2 minus mu1 equal to, that is refractive index of second medium divided by V minus, it is mu1 by, this is required formula for concave refracting surface when object lies in radar medium, and this object is here virtual image. Here, so you have to remember this equation, and this is only one concept. That concept mu2 minus mu1 by R, which is equal to mu2 by V minus mu1 by R. When ray traveling rather to denser medium or any other medium, you can use this concept and you can solve different type of numerical. Now let's start. Case number 2, for spherical refracting surface which form a virtual image if object lies in denser medium. So here we have to draw a concave spherical refracting surface. Suppose this is a concave spherical refracting surface, and whose concave side which is exposed to the radar medium, and this medium is radar medium of refractive index, suppose mu1, and this medium is denser medium or refractive index, that is mu2. And this is small aperture, we use a small straight line is known as principal axis. So this axis is principal axis, and you already know the distance between pole to center of curvature, that is r means radius of curvature. And here we always use the assumption the aperture is very small. Again, the rays should be partial, and the object is here point object. Angle of incident and angle of refraction is very small. So suppose there is an object O which lies on the principal axis but inside the denser medium. Now the incident ray traveling this direction and which strike the interface separating by two medium at point A, and this is the actual line of action of incident ray. Now we have to draw a tangent and we have to draw a normal, and that normal which passing through the center of curvature, that is C. This is normal, and here this point is M. Here, okay. So when light traveling from denser to rarer medium, it changes its direction and it bends away from the normal, not towards the normal, away from the normal. So this refracted ray traveling this direction here and which appears to meet on the principal axis at point I. Here this refracted ray which appears to meet principal axis at this point. If we again incident a second ray which normally on the pole or normally on the aperture, and this ray which passes on negatively this direction, and these two rays are virtually meet at this point I, which form a virtual image, and this ray is known as refracted ray. So what is angle of incident here? So this point, angle of this point is A. So here angle of incident, that is the angle made by angle of incident and normal. So this angle is known as angle of incident. Similarly, the angle made by normal and refracted ray, the angle made by this normal and refracted ray, this total angle is known as angle of refraction. Now we have to draw a perpendicular from point A which meet at point B on the principal axis, and it meet perpendicularly, and here the point P and point B are very close to each other, very close to each other. Clear? Okay. Suppose this angle is taken to be, suppose this angle alpha, and the angle made by image is suppose beta, and the angle made by normal with principal axis and taken to be gamma. Again we have to use Snell's law at this point, because there is one refracting surface which separated by two medium of different refractive index mu1 and mu2, and if we use Snell's law here, by using Snell's law we can write, that is sine of angle of incidence divided by sine of angle of refraction, which is equal to refractive index of second medium. This medium is second medium, which is rarer medium, and this refractive index mu1 with respect to first medium where incident ray traveling. Clear? So second medium means where refracted ray travels, first medium means where incident ray travel, and here refractive index mu2 and here refractive index mu1, or this can be written as, that is mu1 divided by mu2. If we cross multiply this relation, then we can write, that is mu2 sin I, which is equal to mu1 sin of angle of refraction. This is equation. But here we use a partial ray, and this aperture is very small. For partial ray, angle of incidence and angle of refraction is very small. So we can write, that is sine of angle of incidence, which is nearly equal to, that is I, and sine of angle of refraction, which is equal to R. And this relation can be written by using this concept, that is mu2 I equal to, that is mu2 R. equation. Clear? Now we have to find the value of I and R. So in triangle, this triangle, consists angle of incident I, and this is straight line, and this is there is a triangle. In triangle O, first you have to choose one triangle which consists I. Triangle OAC, this triangle OAC, this triangle like this, and this angle OAC, this is alpha, and this angle gamma, and this angle of incidence I. So triangle OAC, I is your exterior angle, which is sum of two interior angle, which is equal to alpha plus that is gamma. Clear? We got the value of I. Now again we have to find angle of refraction R. And look at this angle R, and look at the triangle, this triangle. In triangle, that is IAC. In triangle IAC, where R is exterior angle, look what carefully this triangle IAC, this angle beta, gamma and R, and this R is exterior angle, which is sum of two interior angle. So here that is R equal to beta plus gamma. Now using the value of incident and reflection in equation number 1, then equation 1 can be written there is I into where alpha plus gamma, which is equal to that is mu 2 into beta plus gamma. And but here alpha, beta, gamma is very small, since alpha, beta and gamma are very small. So this quantity can be replaced by their tangent, that is alpha can be written that is tan alpha, beta can be written that is tan beta, and gamma can be written that is tan gamma. Clear? So if we use this alpha, beta, gamma, this equation, the name of equation turn to be that is mu 2 tan alpha plus here tan gamma equal to mu 2 tan beta plus here tan gamma. This is equation number 2. But we have to find the value of tan alpha, tan gamma, tan beta. So now calculate the value of tan alpha, beta and tan gamma. So value of tan alpha which is equal to perpendicular upon base. Now we have to choose a right angle triangle, that is tan alpha. This consists alpha. So this is base angle, this is perpendicular, this is base. That is in triangle OAB. In triangle OAB, alpha is base angle and AB is here perpendicular. So AB divided by OB, that is OB, or we can write, we can replace B in terms of P by, because B and P are very close to each other. So we can write that is AB divided by OB, and the value of OB can be write OP, that is PO. So we can write that is PO. Again, that is tan beta, and the value of tan beta, look at this triangle IAB. In right angle triangle IAB, beta is base angle, and here AB is perpendicular and IB is that is base. So here that is perpendicular by base equal to, and perpendicular AB divided by their base IB, and we can replace B in terms of P, and we can write that is IP or PI. So this relation can be written as PI. And again now alpha, beta, gamma, which is equal to perpendicular upon base. Now look at the diagram. This right angle triangle here, this is alpha, gamma, and triangle CAB. Gamma is base angle and it is perpendicular, and this side BC is base. So you can write that is AB divided by BC, and we can replace B in terms of P. So you can write here that is AB by BC. Now we have to convention. So by using sign convention to the above relation, then first we have to find the value of PO, next the value of PI, next the value of PI, and the value of BC, the value of here, that is BC. So first find PO. Now this is the direction of incident ray. This is ray of incident, because this object here, this is incident ray, and the distance always measured from pole. So this is the direction of incident ray, and PO distance. This distance is opposite to incident ray, and this distance is known as object distance, which is Q, and this PO distance is taken to be negative. Why? Because this distance is measured opposite to the direction of incident ray. Similarly, PI, this distance is known as image distance, and this image distance always measured from pole to eye. So this is the opposite direction of incident ray, and this can be written as minus V. Similarly, that is PC, and the distance PC always measured from pole to center of curvature, which is along the direction of incident ray. So this distance can be written this positive sign of radius of curvature. If we use this relation here, then the relation can be written here, that is AB divided by PO, and the value of PO is minus Q. Again, that is AB divided by PI, and PI is here, that is minus B. That is AB divided by BC, and BC which is equal to plus I. Here, if we use the value of tan alpha, beta, gamma in the above equation, in equation number 2, so from equation 2, we can write by using all the data of alpha, tan beta, tan gamma, then we can write here, that is mu 2 into tan alpha equal to 80 by minus Q. So here 80 by minus Q plus tan gamma, that is 80 by R. So here 80 by R equal to mu 1 into that is tan beta, and the value of tan beta 80 by minus B. So here we can write 80 by minus B plus here again tan gamma, and the value of tan gamma 80 by plus R. That is 80 by plus R. AB on both sides cancel, because this is common term, so the remaining part can be right. That is mu 2 by Q, and here negative sign, then plus mu 2 by R. Mu 2 by R equal to, that is minus mu 1 by V plus, that is mu 1 by R. Now rearrange the term here, radius of curvature and radius of curvature, so we can write, that is mu 1, if you take this term right hand side, then here that is mu 1 by R minus mu 2 by R. But if you take this term, negative term, towards left hand side, then this term can be written mu 1 by V, and here that is mu 2 by U. Here, but this relation can be written, that is mu 1 by V minus mu 2 by U equal to, here R are common quantities, so we can take LCM R, mu 1 minus mu 2. This is the required formula when object lies in denser medium in case of concave spherical refracting surface, and it forms a virtual image, and that virtual image also lies inside the denser medium. Here, these are all about refraction test plus spherical mirror, and that type of spherical mirror is known as concave spherical refracting surface. By using this concept, you can solve different type of numerical. Thank you.